this system, y of t equals t times x of t. We want to test if it's linear. So what does this system do? It takes some input x and it multiplies it by the time. That's what it does. It takes the input and multiplies it by the time. Let's test if that's linear. So we're testing additivity first. After that, if it passes, we test homogeneity. So additivity first. What we do is we look at x1 of t as it goes through the system. It comes out simply as t times x1 of t. And x2, it goes into the system and pops out as t times x2 of t. And if I add those two outputs together, I get t x1 of t plus t x2 of t. And I guess we could rewrite that as t into x1 of t plus x2 of t. And to test for additivity, I just do the exact same thing again, but this time I add the signals before they go into the system. So x1 plus x2, that's what goes into the system, x1 plus x2. And the output is simply the time multiplied by the input, because that's what my system does. It takes the time and it multiplies it by the input. So the input was x1 of t plus x2 of t. And for this test of additivity to be successful, these two expressions need to be exactly the same. And clearly they are. They're the same. So, therefore, we conclude that the system is additive. So we've just shown that the system is additive. It's passed the test of additivity. But that's not enough to demonstrate linearity. We still need to test to see whether the system is homogeneous. So we do exactly the same thing, but this time it's really easy. We just have one input, x of t, and we apply it to the system once after multiplying it by some constant, a, and once we scale after it comes out of the system. So if x of t is multiplied by some constant, then we just have a times x of t. And if that goes into my system, what's the output? Well, let's go back and check what the system does. The system takes my input and multiplies it by time. That's what my system does. It takes the input and multiplies it by time. So my input to the system here is a times x of t. So that's a times x of t, and it's multiplied by time. So if I look at the second block diagram, x of t goes in, so what comes out? T times x of t, because that's what my system does. It takes my input here and it multiplies it by t. That's what it does. And if that is then multiplied by some constant a, so all of this gets multiplied by a, what happens? I simply have a times x of t times t. And that is clearly the same as that. So what does that show us? It's demonstrated that the system is homogeneous. So the test of homogeneity is a big pass. So if it's passed homogeneity and it's passed additivity, it's an additive system, and it's a homogeneous system, we can say, therefore, it is a linear system. Okay, so we've just demonstrated that the system y of t equals t times x of t is a linear system.